completing the square. All right, so to understand completing the square, you have to understand a special pattern when we factor, okay? And if you think back to Algebra 2, I hope you can remember several patterns. Difference of two squares. Do y'all remember that? Yeah. The most important one, though, is, especially when completing the square, is what we call a perfect square trinomial. Or a PST. Okay? And so I'm going to set it up for you and run you through a couple perfect square trinomials before we walk through how to complete the square. All right, so a perfect square trinomial means, there's two ways it can look, so I'll do them both. It means that the ends, trinomial means three pieces, right? So I got 1, 2, 3. 1, 2, 3. Both ends are perfect squares. That's criteria number 1. Criteria number 2, the second sign has to be a plus. And criteria number 3 is if you take, this is the hardest one to remember, if you take the square roots of the ends, so the square root of a squared would be a, the square root of b squared would be b. You take the square roots of the ends, you multiply them together and double them. That has to be what's in the middle. If all three of those things are true, then you have a perfect square trinomial. Now, I'm missing something here. What am I missing? The first sign, right? That's because it can be either a plus or a minus. So once I check these things and I look and I figure out that I've got a perfect square trinomial, it tells me that in order to factor it, it's super easy. I take the square root of the first sign, and the square root of the last squared. And it factors. Do y'all remember this? Okay. A little. Now, you can multiply A and C together, factor and slash, but some of these numbers get big, so it gets kind of hard to do that. And this is a nice, easy shortcut when you can do it. So let me show you a perfect square trinomial. Let's say I had x squared minus 10x plus 25. Is that a perfect square trinomial? Yes. The ends are both perfect squares. Do we agree? X squared is a perfect square. 25 is a perfect square. The second sign is a plus. And the middle, what's the square root of the first? 1 what? 1x. What's the square root of the last one? If you multiply those two things together and then you double them, do you get what's in the middle? Yes. So that's how I know it's a perfect square trinomial. Okay? So that means in order to factor this, I do x minus 5 squared. I don't have to do the a times c, what multiplies, what adds, any of that. I just multiply them. I just factor it using the shortcut. You remember it? One more. Perfect square trinomial, yes or no? Yes. Okay. How does it factor? Parentheses, what goes first? What? 2x? What sign? What goes last? Okay, this is convenient for a couple of reasons. If I had an equation, let's say I had 4x squared plus 12x plus 9 equals 13, and I was asked to solve it. Okay, if I knew that this was a perfect square trinomial, or if I had this, how might you be able to solve that? How many x's do you see in there? 1. It becomes a sad map problem. So that I can just take the square root and then I can solve from there. Okay, so that's the whole reason that it's convenient. Now, what we're going to do is we're going to take equations that are not perfect square trinomials. We're going to make them be a perfect square trinomial, and then we're going to factor and solve them. That's called completing the square. Y'all ready? Ain't nothing to it but to do it. All right. I'm going to do you a little step sheet. How to complete the square. Let's see. Let's say that I have... These can get kind of nasty. Yeah. We are. We're going to, yep, we'll do that. First thing we want to do, though, before we do any of that, is we want to make sure that our equation equals 0. In this case, it does equal 0, so I'm okay there. The next thing you have to do, and we always hope there's no leading coefficient, but if there is a leading coefficient, and there is a leading coefficient here, we can't have that. So we have to divide everything by your leading coefficient. Okay, because we do not want a leading coefficient. We can't complete the square with it. So if you look at this equation, that means I have to divide everything by 4. The first one's easy. 4 divided by 4 is 1. So I've just got 1x squared. And 20x divided by 4. But this one, ugh. And so I'm just going to leave it as a fraction, and I will worry with that in a minute. Okay? Now, Alex was absolutely right. He said I needed to move that 17, and he's right. The problem is I do not have a perfect square trinomial right now. Do you agree? 17 over 4 is not a perfect square trinomial. It's not a perfect square. So it's not going to ever make a perfect square trinomial. So what I need to do is I need to move my c. Okay? That is a bad c. It does not make a perfect square trinomial, so I need to move it. The only way to move it is subtract it, right? Now, when you do this, what you need to do is... Oh, thank you. I'm Bluetoothed in because my HDMI port's not working. When you move your C, leave a space for a C that we're going to find that works. Okay? So just leave a blank there. Over here, I've got negative 17 over 4. But because it's an equation, whatever I put in this blank, I'm going to have to put it over here also. Okay? So put a blank on both sides, and that's really what we're going to calculate to find the perfect square trinomial. I told y'all this is a little tough. To find your good C, you're going to take B, that's in the middle, divide it by 2, and square it. I could have picked an easier first example. I apologize. None of the Algebra 2 concepts in here are easy examples. B is -5, right? All right, so my good C is going to be -5 divided by 2 and squared. What does that become? What's 5 squared? What's 2 squared? Leave it as a fraction. It'll make your life a little bit easier. I know it doesn't seem like that, but it will. Put it on both sides. We did all this work so that the left side would be a perfect square trinomial, and now it is. Not a lot. Remember now, I'm explaining it to you, so it takes a little bit longer. The amount of work, though, look at the left. It's not been a lot of work. You don't remember this from Algebra 2? Really?
I really did not learn. Like the part we was running yesterday.
Do you remember good C and bad C and?
Not this.
You explained it the same way.
Yeah,
Like you teach the exact same way.
I do. Yeah.
It's kind of weird.
Some of these things I've taught for so long, but I don't know how to do them another way now. All right, so now I'm going to factor. All right, so I'm going to factor and solve, and I'm almost done. I promise I am. How do you factor the left? It's a perfect square trinomial. What's the square root of the first one? 1x. First sign. What is the square root of 25 over 4? Do the square root at the top and the square root at the bottom. What's it become? 5 and 2. These two are nice because they have the same denominator, right? Negative 17 over 4 and 25 over 4 give me what? What's 17, negative 17 and 25? Negative 8? No, positive 8? Is it? So it's 8 over 4. Oops, and this is going to square. 8 over 4 is what? 2. Look how nicely this is working out. Does this look like something you can solve now? I hope so, yes. This is a sad math problem now. Tell me what to do. So now I have x minus 5 over 2. Don't forget your plus or minus. And what? Add that 5. I'm out of room. I'm going to come over here. When you add that 5 over 2, you get 5 over 2 plus or minus square root of 2. So this is coming from number 18 in the work you're going to have tonight. The directions say solve by completing the square. I have 3x squared minus 6x minus 7, and it equals x squared plus 3x minus x times x plus 1 plus 3. See? The most. But listen, when you clean it up, it's not that bad. All right. Yes, I definitely would. So you want it, it's got to equal 0. We know that's the first thing, right? So before it can equal 0, before I can start moving things, I need to get rid of things like these parentheses and make sure all my like terms are together. So what I'm going to do first is go ahead and distribute this negative x. Okay, so I've got x squared plus 3x minus x squared minus x plus 3. Looking only at the right side right now. What do you notice has happened? The x squared's gone. That's exactly right. An x squared and a negative x squared cancels, right? What else do you notice has happened? What else do you have? The 3x and the negative x would give me what? 2x and then plus 3. I'm going to put the other side back. And suddenly it doesn't look quite so bad anymore, right? What should I move? Should I move the right side left or the left side right? Left side right. There's only two terms here. I'm going to subtract 2x, subtract 3. Oh, this is going to be a nasty one. This is the hardest one. They definitely get harder as you go, and I waited till we got to the hardest one to do with them. Yeah. It does. It's not. We're going to make it be a perfect square trinomial. It's not right now. It's definitely not. All right, so step 1 done. It's a lot of work for step 1. What's step 2 say? Divide everything by the leading coefficient. Now, if you don't have a leading coefficient, you skip that step. Do I have a leading coefficient? Unfortunately, I do. And it's a terrible leading coefficient because it's a 3. And none of these numbers are divisible by 3 except for the first one, which means I'm going to have a whole lot of fractions. All right, so I got x squared minus 8 over 3x minus 10 over 3. What's my next step say to do? Move the c. To move it, I have to do what? Add it. When you do this, leave a blank here. And leave a blank here. Now here comes the blah part. How do I find a good c? b over 2 squared. What happens if my b is a fraction? Yes, you're exactly right. b over 2 is the same thing as 1/2 times b, right? That's going to make it easier to divide by 2 on the fraction, okay? So I've got 1/2 times 8 over 3, and once I do this, I'm going to square the whole thing. It's pretty, for sure. All right. Multiplying fractions is top times top and bottom times bottom, so I get 8 over 6. Can you simplify 8 over 6? 4/3. Squared would be 16 over 9. That's going to go here, and it's going to go here. And I am going to tell you, I am definitely going to use my calculator on the right because I don't want to have to add those fractions together myself. All right, so factored on the left, the square root of the first sign, and what is the square root of 16 over 9? What's the square root of 16? 4, and the square root of 9 is 3. 4 and 3. This, I'm going to do on my calculator. I've showed y'all how to do this, right? We do 10 divided by 3 plus, what was it? 16 divided by 9. And I need it back in a fraction. So I hit math, enter, enter. Ooh, child, aren't you glad you didn't do that by hand? 46 over 9. Now you should be to a place where you can stop. Your hard work's done now. Yep. I was doing the square root of this one. The square root of 16 over 9 is what goes right there. Yeah. Today it will. But once we do complex numbers where we get into the imaginaries and stuff, it may not be. All right, so to finish solving, all you should have to do is do the square root. Plus or minus, 46 does not have a square root, but 9 does. It's 3. And then all you have to do, I'm out of room, is add the 4/3 to both sides. You looked away.